I've been trying to figure out how to package this Amphenol Advanced Sensors, Environmental Sensors package for quite a while now. They have an Arduino Uno clone that made by Amphenol, and I've mounted it in this base package here on some standoffs, which are threaded. And on top of that, we put a shield that allows us to interconnect the sensors. And I put a lid on that, which goes like this. But first we have to put the battery in. The battery drops in like this, and I have to thread the cable underneath so that we can plug it in here. Just showing you how it goes. So this will go on top, it snaps in, and I'll screw it in place here with these 4 screws. And on top of that, we'll have this sort of mezzanine superstructure which covers up all these connectors. It goes here and it screws in with 4 screws. And then the CO2 sensor will go in here. The display will mount in here. And the particle detector will go in over here. Not all that easy to see with black chassis, but let me get some screws and put that together. There's also a little bezel to hide the circuit board for this display, and it will snap on over the display like this. So let's put some screws to it. Okay, here's what it looks like all together. You can see the Amphenol sensors are reading 1434 parts per million for carbon dioxide. I guess that's flashing a bit on the screen because of the synchronization of the refresh rate. But the package works. It's nice and solid. And we've got a power button on the battery right here. See how long it takes to boot up. Telair eval module. Dust sensor. Carbon dioxide. It starts up high at 1100. Wow, yeah, the refresh really messes up the screen here. But carbon dioxide is coming down, 682. After it needs to warm up for a few minutes before it gives you a really good reading. 593. The ambient should be somewhere just over 400 in a well ventilated area. This is not a great area for ventilation, so it's at 576, 585, and if I breathe on it, maybe it'll go up. $697. There we go, 1391 parts per million of carbon dioxide because I was breathing on it a little bit. 1964. That's cool. So it definitely has a lag. It takes a minute or two for the carbon dioxide to register and stabilize. But now that I have this together, I can take this anywhere, like into meetings, for example, in boardrooms or conference rooms where there's a lot of people in a small space, and just see if the carbon dioxide builds up in the room. One tricky aspect of this packaging exercise was that the CO2 sensor needs to be exposed to air, and so does the dust sensor. So I'm going to try and see if this can register pollen, but because it's just about pollen season now. But it was tricky to design this so that those two sensors were still exposed to the air, and leaving the display visible and access to the battery. So we're back down to 570 parts per million on carbon dioxide because I'm not breathing right on it. But it took me a long time to get this thing packaged up, and I was just trying to figure out how to make that look reasonable. It's still not super attractive or anything, but it's at least functional.